Hello, Algebra 3 trig students. We are going to begin to look at graphing functions. And I will highly recommend that you have something out that is going to help you graph. So I am going to be demonstrating using Desmos here, but you can certainly use your graphing calculator. But Desmos is probably one of the easiest things to do as far as graphing. So the first thing when we talk about graphing functions is that you are going to see f of x equals instead of y equals. And that's really nothing to worry about, right? If we just use function notations when we're talking about functions, but the f of x in either case is still going to be the output of our function. Okay, so the first thing is the function, the vertical line test tells us if it's a function or not. So for the vertical line test, if you draw a vertical line and it intersects your graph twice, then it's not a function. If it hits it once, then it is a function, right? That just has to do with the fact that we don't want our input values to repeat or to go to multiple output values, right? So to be a function, each input must have one and only one output, okay? So to look at this first one, sketch the graph and find the domain and range. Okay, so the first thing we're going to look at is we're going to look at finding the domain. We've talked a lot about domain before, and the big thing here with domain with the square roots is that whatever is underneath the square root, in this case x plus 1, that must be a positive number, right? We are not able to take the square root of a negative and get a real answer. So to find the domain, we are going to do x minus 1 has to be greater than or equal to 0. Again, that's because we want that number to be positive. So we get that x is greater than or equal to 1. Now we are going to turn that into integral notation, right? 1's our minimum value. We have the or equal to, so it's bracket, comma, infinity. Okay, and then we will look at the range later after we graph it. Okay, so now at this point you can go over to Desmos and you can type in, or if you use your calculator button here, you can do the square root, and we're just going to do the square root of x minus 1, right? So we kind of get this general shape here. And if you want to, you can kind of look at dots. So we have the point 1, 0, we have the point 2, 1, and then it looks to be about 5, 2. So then we can hop back over to our graph, right? We have 1, 0, we have 2, 1, and we have 5, 2. So we kind of get this general check mark here. So now as far as the range, again, this is talking about our output values or our y values. So if you notice, this entire graph is going to be above the y-axis, or sorry, above the x-axis. So our range, because it goes above the x-axis and it goes kind of up gradually forever, it's not going to be a steep increase, right? So our minimum value is 0, right? And we know it does hit 0 because it hits 0 right here. And it's going to go on and continue to positive infinity. So that's kind of a sketch of how you can use it. Again, I wouldn't bother making a t-table to make these graphs. Simply, you can make a graph by using Desmos and just plotting some points then that you see. Right? Next one. Square root of 9 minus x squared. Again, we want to know when is this greater than or equal to 0. So to find our domain, right, we are going to do the square root of 9, oh, sorry, not the square root. For our domain, we are going to figure out when is 9 minus x squared greater than or equal to 0. Right, so really 9 is going to be greater than or equal to x squared. So what this tells us is that we can take the square root of both sides, that x has to be less than plus or minus 3, right? Because when you take the square root of both sides, we add the plus or minus, the square root of 9 is 3. So our domain is going to be between 3 and 3 inclusively. So again, to graph this, we can go back to our Desmos, do our square root function, square root of 9 minus x, and then you hit the caret to get your exponent x squared. So what we get here is this little semicircle, and we can look at these points. So we have 3, 0, or negative 3, 0, 0, 3, and 3, 0. So then we can plot these points. So we're going to put at negative 3, 0, 3, 0, and sorry, 0, 3, and 3, 0. and we kind of get this little semicircle. So now our range, again, is our output values. The lowest output value here that we see is 0, right, because it doesn't cross the x-axis. And the highest it goes up, or the maximum value, is going to be 3. So our range is going to be sandwiched between 0 and 3. Okay, moving on.